Hi everyone. I have around 9 years of IT experience. In that first 6 or 7 years, 6.5 years to 7 years, I worked on data warehouse and BI modules. And from past 2.5 years, I'm working on big data and the corresponding Hadoop ecosystem. We implemented one full lifecycle project on big data, and now it's running in production. We are implementing second project right now, parallelly. I have extensive experience on, different versatile domains like banking, insurance, and healthcare. There are three domains I mostly worked on in my entire career. That's a basic introduction about myself. First, we will start with the introduction of our big data. With Hadoop ecosystem also we will explain. I'll start with the what is a distributed file system? What are the problems with the traditional large-scale distributed file systems? We will also discuss about what are the traditional large-scale systems available, what are the problems especially. Then we'll go for introduction. While we are explaining about the basic concepts, I will use some presentations as well as some project documents also. Just a second. So we will start with what is a distributed computing, distributed file systems available, and what are the challenges we have in the distributed file system. Especially the main challenges when we go for the distributed file system is a fault tolerance. In case of any of the system is down, if you want to make the system again available, it's going to be a big process. Backup and recovery process is big challenge in distributed file system, distributed environments. How we are achieving these challenges with big data environment, and how we are going to have a data growth from the past few decades, and why we need to come into the big data. We see that even few people also working on worked on mainframe, and myself also have experience on data warehouse background, right? We all came from the data environment, data maintenance background environments. If you see in most of our organizations, in olden days, we have a mainframe system, then later we have a client server system, and internet, now social media and cloud, mobile. As decades are going on, years and years of data, when we are having that huge amount of data is producing every day in every business as well as every our day-to-day life activities. To maintain this much data, an existing RDBMS systems will not be able to support. Because of the data is huge amount of data is generating. That data also not a 100% similar kind of data. Some data is structured data, some data is unstructured data, some data is semi-structured data also, and the velocity of the data is also high, and the data is also coming in different varieties. Because of these three V's, especially volume, velocity, and variety, the existing RDBMS systems, even I also worked on data warehouse, right? Data warehouse, we are going to place data, all structured data. As we are going to load the data into all structured data, and that's also going to become a database environment. Especially that database, if you want to process XML files, web logs, audio, video files, we want to process, and if you want to maintain that data, and if you want to use for reporting, we need to do huge process in background. Because of varieties of data is retrieving from the business nowadays, mostly different varieties of data. Like if you take in healthcare examples, healthcare products, when you see, we are going to get the data from digital devices. We are also going to get the data from XML files, audio, video, and social media network files. These all we need to maintain. Because of these, RDBMS cannot fit this much volume of the data, this much varieties of the data, this much velocity of the data. That is the reason they are looking for. I mean, most of organizations are looking for other alternative that was implemented with the big data. Okay, in actual class we will also discuss what kind of volume of the data will come and how we are going to maintain, and what is the base to develop Hadoop actually. We are telling that Hadoop is an open source ecosystem, open source set of libraries which we have. These set of libraries will be useful for creating a big data. See, somebody told that I am working on Informatica. I also have experience on Informatica in my starting of my career. Then I moved into data stage, ETL tool, right? As I have a knowledge on Informatica and ETL, these are ETL tools which are used to create a warehouse. Similarly, Hadoop is an ecosystem. It's an open source ecosystem. This ecosystem is used to implement a big data. How we implemented a big data? What is the base for big data? Before 1995, we have so many search engines are available in the market at that time. Yahoo, Infosec, like us, Alta Vista, XIT, Computer, the other search engines are available. But in the year of 2000, there was a one search engine came and they all are replaced with the search engine with the different search algorithms are going to be used in the Google search engine. But in the era of Google, 2000, Google was number one search engine, and it provided a huge competition to the other search engines that exist at the time in the market. But later on, when the years are going, as Google also released different products, I think around 60 plus products right now Google has, like Google Earth, YouTube, and even in olden days, which we use, most of people use Orkut, right? Google Maps, Google Drive. Like this, they have 60 plus products are available. As these products are increased, the data which is generating by all the web is high. Now to maintain the data, Google started facing a problems. What the history means? Google developed in the year of 2000, plus later it started gaining pains because this much data to maintain, and this is also not in the same format. Some data is structured, some data is semi-structured, some data is unstructured. So all the kind of data to maintain, Google has started struggling with the problems. Google plus growing pains plus solution is equal to 3 white papers. Google released 3 white papers. One is GFS. What is this GFS means? Google File System. This is a base to develop a HDFS in Hadoop. In Hadoop, we have a concept called HDFS. HDFS was developed based on the white paper which is released by Google in the year of 2003. See, even though before GFS was implemented in our businesses, we have distributed file systems are there to distribute the data across the cluster. But those distributed file systems are having some challenges. With overcoming of those challenges, Google implemented a GFS. This GFS is the base for HDFS in Hadoop. What is this HDFS means? Hadoop distributed file system. And they also see, they are storing right now data across the cluster. Good. We are storing the data across the cluster. In case of any mission down also, we are not going to bother about that because immediate backup is available, as well as we are also creating a replication concept. I'll just show you. Wait for a minute. What is this replication and everything? Once I distribute the data across the cluster, then I want to perform calculations across the cluster, right? Not only storing the data across the cluster. After storing the data, I stored my data across the cluster. I have a 1000 node mission. When I store my data across the 1000 node mission, then I want to do calculations on those 1000 node mission also. To do distributed calculations or distributed computing, we have a concept called Mapreduce. This Mapreduce also was developed by Google Fellows. This is also released in the year of 2004. This Mapreduce has its own algorithms. Those algorithms, okay, we are going to write and we are going to execute and we are going to get the distributed calculations. While you are writing this Mapreduce algorithms, we are going to use in, especially when it comes to Hadoop environment, we are going to write with some programming languages. We can write these Mapreduce algorithms with Java or .NET or Python. These kind of languages we are going to use and we are going to do distributed calculations. And next, as we are getting the petabytes of data right now, nowadays, see, most of databases, whatever we have in the market right now, around 22 databases are there. These databases are going to store terabytes of data. But nowadays, we are generating or we are getting the data from the source with the petabytes of information. As it's coming with the petabytes of information, to store that much petabytes of information, we need some storage system that's special to store structured data, that is big table. This big table is a concept which is not implementing any SQL queries. See, it's also a kind of tables, but it's not a SQL database, no SQL database, simply speaking. Based on this big table concept, there was a concept developed in Hadoop ecosystem, that is HBase. So these three are the white papers which are based for implementing a Hadoop ecosystem. Okay, let me go for what is this Hadoop and everything. Yeah. If you have any questions, you can just ping me in chat. Okay, we'll answer your questions. Right. See, this is about the basic introduction what we are going to discuss. We will discuss about the what is distributed systems, problem with the distributed systems, introduction to Hadoop, brief history. We'll also discuss about history of the Hadoop, how we achieve this. What is Hadoop? Okay, history we'll also discuss. Then we'll go for the versions. What are the versions are available? In our session, we are going to discuss about the 2x versions. In olden days, yes, we use the versions 1x version in our companies also. Now, companies are also migrating to 2x version. There are a lot of versions are available. There is 1x version and 2.x, 2.0 version are stable versions, and some other beta versions also released by our Hadoop vendors. Still, there are some enhancements of doing for those versions. Especially when we compare with the 1x version of Hadoop to the 2x version of Hadoop, what the basic differences means. This name node will not store any data. It just stores the metadata information. As name node stores a metadata information with 1x versions of, it's going to have only one name node which is connected to n number of data nodes. And in 2x version we are having many name nodes. There is a concept of many name node concept that we are going to call as a name node, namespace. There will be namespace available. See here, one name node, second name node, like this. We are going to have in 2x versions, and in 1x versions, yes, this Hadoop systems, whatever we are maintaining the data is going to be a high availability, means there is no guarantee. But in 2x versions, yes, in case of any machine is down, also immediately we can shift the data to other nodes, and we can recreate it. And processing control means it's having job tracker and task tracker. It's having resource manager, node manager, app master. These are all the different components are available, which are useful to create a big data. Here, what is this big data? I'm just giving introduction background process. Now let me go to what is big data. Big data is nothing but a huge petabytes of information which we are maintaining in a distributed system. To store this huge petabytes of information across the distributed cluster, we are using an Hadoop ecosystem. This Hadoop ecosystem has different ecosystem components are available. These will be useful to implement big data. Let me just give you what are the different ecosystem components are available in Hadoop. See, like if you want to create a data warehouse, you told that okay, I have an experience of ETL tool like Informatica, then After the reporting tool will be there. Before ETL and reporting started, we also have modeling, right? Similarly, in Hadoop also, we have different ecosystem components are there. The place where we are going to store our data is nothing but a HDFS. Okay, in our session, after basics part completed, like okay, scaling with this one and RDBMS to Hadoop differences, introduction to Hadoop ecosystem will start. Then business case and healthcare and banking also will discuss. See, especially when you go for this one, where Hadoop ecosystem will start with the HDFS. And this part, the second, one is going to discuss about the how to do cluster setup on our machines. Here, cluster setup in the sense we can do cluster setup on Windows or Linux or Unix or Mac OS. Any of these OSs we can do this cluster setup. We will also discuss in our class how to do cluster setup and how to get these all, because our Hadoop is a open source software right now. Anyone can download from Google and you can also install. It's a very simple process. Which operating system you want to get installation, that operating system we can do on Mac, we can do on Windows, we can do on Linux, and we can do on other third-party OSs also. That cluster setup also we will discuss, and at the time of once that is done, a cluster setup is done, we'll go for the ecosystem. That ecosystem is we'll start with a HDFS. In this ecosystem, if you observe, what are the main components are available in this? The first one is HDFS. What is the full form of HDFS? Hadoop Distributed File System. The place where our data is going to store in our Hadoop ecosystem is nothing but a HDFS. This HDFS will have two main components are available inside that one. One is called name node, one is called data node. Let me just show you that also. What are the PPTs I am showing here? I'll share you the PPTs to you. Those you can use for your reference in future. See. Just an example. This is a huge amount of data file I'm getting. You have, for example, 30 GB or 50 GB file. This is called master. In HDFS, this is called name node. They are called data nodes. These data nodes are the very normal missions, okay, low-end missions, and this name node is a very high-end mission. Name node is a high-end mission, and data nodes are the very basic missions are available. And name node is going to maintain a kind of a master, and they are called slave missions. And this master is going to maintain the metadata, and the slave is going to maintain data. When this file data we want to store, before starting, there is a client software installed in our Hadoop, that is HDFS client. It will going to communicate to our master mission, that's called name node, and it will get information back to HDFS client. What information we are going to get back here means which particular data node I can store data, and which are free, which are busy, those information, those kind of metadata information will get back to client. Then after receiving that information back to client, then client will divide this biggest file into n number of blocks. While we are storing the data in across the cluster in Hadoop, the data is going to store across the cluster in a format called blocks. What are these are the blocks available? A block is nothing but a small piece of data which is going to be 128 MB to in maximum 512 in between those 512 MB. These blocks are going to store across the cluster in a distributed fashion, and each block is going to create with the replication factor of 3 or 5 or something. Means this is one small block. See, this is one small block which is storing across the cluster in 3 copies. Copy 1, copy 2, copy 3. Why should I maintain? In data warehouse, when we are maintaining the data, am I going to maintain like this? No, there is no concept like. But when we are implementing Hadoop, big data implementation we are doing with using of Hadoop. In HDFS, there is a concept we have that is called replication. What is this replication? A replication is nothing but the creating of multiple copies of same data. Hadoop recommends, Apache Hadoop recommends at least 3 copies as required to store the data into the multiple data nodes. What is the advantage of this replication? When you go for HDFS, if you are storing the data in replication, right? What is the advantage after storing this entire data? For example, just on one fine day, in case if this machine is down, means there is a fault tolerance. If any of the machine is down, am I going to lose any single bit of data? No, right? Why? What are the data is already there in this machine? Those are also backup available on these machines, right? If this machine is down, how this name node knows this machine is down means from this normal commodity machines to this machine, there will be communication is there, that's called heartbeat. Always data nodes will send a heartbeat to name node, then name node will recognize whether these data nodes are working or not. If those are working, we are good. If those are not working, if data nodes are not working, in case of a heartbeat is not receiving properly, then our Hadoop ecosystem itself need to create a auto replications. Actually, block block copies should be 3, right? When the other machine is down, there is no other copy. That copy is creating right now as a 4th copy in this one, and similarly other also. Like this, it will going to create extra copies. And after few days, for example, this machine may be down, main machine. If main machine is down, that's called single point of failure in the Hadoop ecosystem. Then there is a backup. We also have a backup. This entire fault tolerance is achieved using of this big data. Okay, that we are going to discuss in HDFS. Before we go for the HDFS and everything, I just want to show you what kind of cluster setup we are going to do. I'm just showing you that. These are the steps I will give you how to do setup and cluster. Generally, Hadoop we can do installation or setup of this cluster on 3 different modes. One we can call as a local mode, second one we can call as a pseudo distributed mode, and third one we can call as a fully distributed mode. There are 3 different modes are available actually. These 3 modes in our organizations, when we are working, we can see fully distributed mode, that's last mode. This fully distributed mode, we are going to have one name node mission or 2 or 3 name node missions with n number of data node missions are available. Those are nothing but a normal day-to-day missions. We will discuss in our session also how to install this one with because this data this one Hadoop is providing by different vendors, Cloudera, DataX, Mapper, Hortonworks. Like this, there are different vendors are providing. Most popular one which using by most of companies and most of people are is Cloudera. I'll show you how to do Cloudera on Windows first. Then see these are the steps actually how to install. These steps I'll explain and I'll send you these steps also along with software. You can just create this, execute these steps in your machine and get installation of this Hadoop on your machine, Hadoop 2.0 version or 2.2.3 version. To get installation of this one, at least you need to have 2 GB RAM is at least minimum required. If you have high-end machine, then it's also good. This is a Windows installation. Similarly, we'll also discuss about the Linux installation also, Linux and Mac, and there are all installations we are going to discuss in our class. How to do single node setup. Just how to perform on a single node setup on a this one. With single node means we have, for example, personal missions. We are going to have one mission only. On the same mission, we want to perform both data node and name node operations. How to set up a single node. Okay, with Linux is the operating system in background. These are the steps actually. We are going to set up some 3 configuration files in background of Hadoop. That is core site XML. This is one configuration file. And second one is HDFS site XML. Third one is Mapreduce site XML. See Mapreduce site XML. These are the XML files we are having. These XML files we need to do configuration setups. That's the one. We will discuss these setups. Okay, Hadoop installation on CDH4 and 2.0 on single node. a multi-node cluster, how to perform on multi-node machines, not only single node. Okay, these are all steps I'll send you. Along with that, I'll show you in class also. Okay, that class recordings also, as I'll going to show you after class completion. The class recording also you will get it. As we are going to get the class recording also, you can just listen and practice as listen and installation. You can do installation by listening also. This is how to do setup on multi-node cluster, and similarly how can we set up this XML files, core site XML, mapped site XML. These also. Yeah. Okay. Once we are done with the setup, then we'll go for a HDFS. The place where we are storing HDFS, in Hadoop data is nothing but a HDFS. I just opened that one. Okay, I'm just showing you that one. Now for this, I'm just going for a Hadoop login. I have right now Hadoop 2.0 version. This 2.0 version installed on my machine. I'm just going for a command line interface where we are going to execute. See, in HDFS environment, we can open the data whatever we stored in HDFS by using a basic Unix commands like cat, touch, rm, basic kind of commands. And similarly, we also have a web interface. No need to go for command line. We also have a web interface. From there, you can open the data and you can go for the other things also. I'm just executing command JPS. That's here. We have sudo JPS. What is this sudo JPS command? I'm just executing. I'll explain in class what is this basic commands also. This is just going to give you a status of your Hadoop services. See, for example, if you are logging into any mission, we want to see the status of services which are running in background. If you see here, what are the services are running right now in my mission is secondary name node, job trackers, run job files, background name node, data nodes, HR region. These are about HBase, HMaster application server like this. And if you want to see the basic commands, Hadoop is the one. You type Hadoop space fs-help. If you type the command of help, just it's going to display that what are the commands we generally need to use in Hadoop. When you are typing any command in Hadoop cluster, you need to use a keyword called Hadoop space -dfs or -fs. Anything is okay. Here fs or dfs means file system. Then I just type a command, base command. That's called help. Okay. What are the command we can execute? Cat command, ch groups, ch mod, ch owner, copy from local, copy to local, count, cp, difference, du, expunge, get merger, help, ls, mkdir. All are different kind of commands we are going to use in Hadoop. Apart from using of this command line, here we also have this. WA is also there. I'm just opening WA. This is WA. How we have this configuration, how much space allocated to our distributed file system, how much used, how much free space available, and if you want to go for the browsing of the file system, you can browse. And I want to just show you where my files are stored. See, I can see the data. See, this is the data. This is some semi-structured data is stored here. This kind of data we can see. We moved file from normal text file environment into HDFS environment, right? This is the data I can see here. By using web UI, okay, you can see chunks information and clusters, summary you can see, and how many replications are there for each file, what is the size of your files, what are the permissions, all those information we can see in HDFS. Okay, HDFS is a place where we are going to store our data in distributed fashion. We will discuss in our sessions also how to store in HDFS, what is the name node, what is the data node, what is the secondary name node, job tracker, task tracker, its functionalities, and heartbeats, how we are going to receive the heartbeats, track awareness, block scanners, trasher, health checkups, and Hadoop archive, how to do archive in Hadoop, and what are the basic commands. I told you now, we are going to use some commands in command line interface, right? When you go for this command line interface, we are going to use commands. Cat command and those commands. How to use those commands? Each command I'll execute in a session. and I'll provide that recording also. You can practice. Before we go for these commands also, I'll just give you some introduction about the Linux commands. Then we'll go for this command. Then it will be very easy to understand and to execute those commands and to work on the HDFS. Once HDFS is done, the storage part, then second we'll go for Mapreduce. See, once we store the data in distributed fashion by using HDFS, okay, we will store the data in, we are going to store the data in HDFS. We will take the data for different data manipulations and calculations operation. That's called Mapreduce. This Mapreduce has set of algorithms. Those algorithms, whatever we have in the Mapreduce, will be useful to do calculations part. While we are doing the Mapreduce algorithms, we need to write a programming, right? Either Java or .NET or Python. These are the kind of programs. If you are not familiar with the programs, even myself also, we are not get a chance to work in my career initial days with those kind of programming languages, right? Before we moved into Hadoop, we also get a good idea and good practice on these programming languages. I will share you Java session, Java core Java session, because we need to know at least core Java part. There are 12 recorded sessions I will provide you. These you can listen in the day one of our class itself. I will provide these 12 recordings. These 12 recordings you can listen and you can practice. You can also get installation of Java, Eclipse. You can practice how to create a Java program, simple programs, how to use objects, classes, methods, inheritance, polymorphism. These are all concepts we are going to discuss in these 12 class of recordings, around 13 to 15 hours of duration. That's at least minimum you need to know core Java. If you want to go for advanced a little bit also, yes, you can go. I'll provide that recordings also. It's going to be, these all will be around 12 to 13 hours of duration we have. These duration sessions you need to listen and need to practice. Then only we are able to write our own Mapreduce algorithms. We need to write some Mapreduce algorithms actually. While you are writing Mapreduce algorithm, we are going to use programming language, that how to write a Mapreduce algorithms, what kind of values we are going to get, what kind of format of the data we are going to get. Okay, how to pass text format, key value format, sequence file formats, how to do debugging of these programs, joining of the data sets, and few business algorithms. While we are using this one, Mapreduce, I'll show you some Mapreduce programs how to write. See, this is a one Java Mapreduce program for healthcare project. I'll show you how to write what kind of classes. Generally, when you're writing these kind of Mapreduce programs, we are having a driver program, mapper program, reduce. There are two concepts, map and reduce. Map is just going to take input data, and reduce is the one where we are going to do calculations and final result. And these two will be managed and run by driver program. There are three programs generally we are going to have. And how to use these classes, these libraries we are going to get, and how to write the classes, public class, and public static class. What is the meaning of static, and what is the meaning of dynamic class? How to create a class, and how to write up these kind of classes. How to write up map functions, producer functions, driver functions. These kind of complete program explanation I will give you, and also I will execute in class. I'll show you a few programs. In class at least, we'll execute few programs, and apart from that, I'll share you so many other programs we are using in our projects. Those also you can practice, and you can write your own situations also for how to do image processing. See, this is one example for image processing. See, if you are not very fond of, you are not interested to write biggest programs like this, we have other alternatives also there. But up to now in 2x versions, we need to write programs at least. In a team, generally we are going to have some Java people also will be there. They are going to write programs, and we are going to just create a jar file and execute that jar file in Hadoop. That's we are going to discuss about the Mapreduce. After that, we'll go for third ecosystem component, that is Pig. See, this Pig was developed by Yahoo people. This also became a top level project in Apache Hadoop in 2008 year onwards. And Pig is a scripting language. Pig itself has a one scripting language. Whatever we are writing in Mapreduce, same thing we can do in Pig also. But Mapreduce is better for unstructured data. If my source is structured data, then it's better to write a Pig script also. It looks like a Unix script, but it has a small difference between Unix and Pig. Pig has this script on separate language called Pig Latin. By using Pig Latin language, we are going to write this Pig scripts. Okay, what we are going to discuss in Pig scripts? Just what is a Pig? Use case of Pig. Pig works in Pig installation and configuration. See, when you install Hadoop also, we need to install Pig separately. When you install, you are going to get default HDFS and Mapreduce, and rest all ecosystem components we need to do small setups, small paths, configuration files we need to change. Then Pig installation is going to be executed, and Pig has two types of modes when you are executing the Pig, that is local mode and distributed mode. And what kind of loading data types, schemas, Pig Latin, user defined functions, how to write a Pig scripts, advanced Pig scripts, even for a Pig scripts also how to write some Pig scripts. See, some healthcare Pig script. Try to open through Notepad. This is the one Pig script. See, Pig is nothing but a small language actually, and it has a Pig Latin language. Let me just show you how that language commands will be there. Even when you submit a Pig script also, one important thing you need to remember when you are executing Pig script in Mapreduce mode, once you submit a Pig script, you are writing 10-15 lines of Pig script. The 10-15 lines of Pig script is going to convert into again Mapreduce program. That will be contacted to the HDFS to get the data. See, Pig is going to use for creating of the data which is ready for reporting, and Pig will take the HDFS data and do some kind of calculation and operations. When you submit a Pig job submission is done, then it is going to go for the Mapreduce jobs, then corresponding HDFS also. It's a very advantage of writing Pig script than Mapreduce. If you write 10 lines of Pig Latin language, that's going to equal to 200 lines of Java program. Mean a simple Pig command will have a background much Java program syntaxes. 10-15 lines of Java program syntax is going to embed in a single Pig command. We will also discuss in our session how to write a Pig script. It's very easy. Pig is very easy than a Mapreduce. That's a very flexible and very fast in development and execution also. Because when you go for the Mapreduce, we need to write a Java program in Eclipse, and we need to create a jar file. That jar file we need to call into our Hadoop environment. But when you go for the Pig, that is not the case. We simply need to write a Pig script in Pig Latin and execute the Pig script. And that script is also very simple commands. Let me just show you some example. Small command how we are going to have. Just a minute. See, there are the commands. Records is nothing but a bag name here. Mean in Pig we are going to call it bags. Records is equal to means records is the bag name is equal to load this file. I have my file in this path. That file data I need to load into this bag. This is the file name, the name of the file where you want to load into the bag. As is a keyword. As this is the schema name. What are the column we have means letter, char array is data type, count integer data type. Letter is a column name, colon, data type. Count is a column name, colon, data type. Like this it is going to create a bag. Once we load the data of the file into bag in Pig, do you want to display the content? For example, if you want to display the data, if it is databases like Oracle, Teradata, these kind of databases, we are going to write a select command, right? When we go for the this one here, we are going to have dump is a command which is going to display the content of the file. Say the content I can get that. Very simple commands. See, that's about the Pig. Okay, we will discuss the example execution of the Pig script, writing a Pig script and how to call the Pig script in our environment. Then we'll go for Hive. Hive is a data warehouse within Hadoop. When you go for Hadoop, we have a data warehouse, right? That data warehouse is nothing but Hive. It's going to have a structured query language in Hadoop, SQL. We're going to have a separate SQL that is HiveQL. We're going to write some HiveQLs in Hadoop. We're going to write some HiveQL. We are going to discuss about how Hive architecture we have. I'm just opening Hive. That stuff. See, this is the Hive flow. Even if you're writing a Mapreduce or Pig also, as well as Hive also, everyone will communicate, and again it is going to create in background Mapreduce. For example, I'm writing a Hive query. I'm executing that Hive query. When I'm executing that query to get the result or to display the result, to insert the data, that query is going to communicate to Mapreduce and generate a Mapreduce program. That Mapreduce program will communicate to HDFS, get the data. That's is happening in Hive. Hive is a kind of normal SQL. Who are having SQL knowledge, that will be enough to work on Hive. Very simple. Hive has its own database, and inside the database we are going to have tables. Inside those tables, each table is divided into a number of partitions, and each partition is divided into a number of buckets. And Hive is going to have two types of data types: primitive data types and complex data types. We will discuss about how to create those kind of queries, how to load, how to write the select queries, those kind of insertion, and how to install Hive, how to set up the configuration, command line interface, how to write some kind of join operations in Hive. Those queries we will write and we will execute group by class, order by classes, those things. See, it will work like a data warehouse. From source directly we can also insert the data into Hive, and we also can insert the data into, get the data into Pig also. From Pig to Hive also we can process, and HDFS to Hive also we can process. We will also discuss about Hive in our classes, around 4 to 5 sessions, and then we'll go for HBase. And we have HCatalog is there. Actually, HCatalog is the one which is going to maintain a metadata information about the Hadoop Hive. In Hive, what are the tables we are creating? Those tables information we are going to use with Hive actually. What are the tables we are having? That's those tables. What are the tables I have in Hive? Those tables metadata information is going to maintain in HCatalog. Similarly, as I told you, in Google, they have a big table. Based on that, there is a concept was developed in Hadoop also. That is HBase. HBase is a NoSQL database. It doesn't require any SQL commands, SQL queries or something. It's going to have very basic commands: get, put, scan. 3 commands only we are going to use. Those 3 commands, whatever we are having, we are going to use there, and we are going to process. How to use those commands, how to process the data, how to load the petabytes of data in HBase, what kind of tables we have in HBase, what type of storage mechanism we are following in HBase. This is all we will discuss in our session. Then we'll go for a Scoop. Scoop is a kind of ETL tool. See, we are working on Informatica, Data Stage, MSBI, SSS, Ab initio, right? These kind of ETL tools. Those are ETL tools to connect with our OLTP systems and get load data into warehouse. Similarly, we have a Scoop. Scoop is going to place a data of structured data which we have in source databases. For example, I have a data in my Oracle database in table format. Those tables I need to read into my HDFS. Those tables data I want to load into my HDFS, or those table data directly I want to load in HBase or Hive also. If you want to load into Hive or HBase or HDFS, we are going to use Scoop for importing and exporting of the relational database data, the structured data only. If you have any unstructured data, if you want to process, we need to go for Flume. Scoop and Flume are kind of import exporting tools which are used to connect with the other environments into Hadoop, Hadoop to other environments. We can extract the data, we can load the data. With using of this Flume, we can import and export the operations data. Weblogs data, audio files, video files, image data, digital sounds. These are all the kind of data if you want to process and if you want to do, we are going to use a Flume. And we'll also go and discuss about Uzi. Uzi is a scheduling tool actually. See, first a Hadoop storing should be happen, means HDFS command should execute. Then Mapreduce should execute. or if you're writing some Hive should communicate to MapReduce to HDFS, then get the data. This kind of scheduling we can do. That scheduling we are going to perform with using of the Uzi. How to do this scheduling and how to specify the scheduling process and everything we are going to discuss in our sessions. And we also go for the Zookeeper, how performing the cluster coordination. See, these are not like a base ecosystem components. These are for cluster coordination. These two, Zookeeper and Umbire. We'll also discuss about how to do cluster coordination using of Zookeeper especially. And along with that, is all okay. We'll have another session. Okay, we'll discuss about Scoop, Flume, and Zookeeper, Impol, and all. We'll also discuss about some project. Okay, one base project also we'll discuss at least 4 to 5 sessions. We'll also give you an overview about how we are going to use these ecosystem components in real-time industry, and then we'll also provide you certification guidance for doing a certification on Hadoop. I'm also a certified Hadoop consultant in my company. You also get certification on Hadoop developer, Hadoop administrator, or HBase developer. There are different certifications are available. If you purely want to work on Hadoop developer side, you can do Hadoop certification, Hadoop developer certification. For Cloudera 1 or maybe Hot any certification you can do. And I'll also show you in class itself, installation and configuration. We'll provide you all the class recordings every day once the class is done. Hadoop ecosystem, those things, Unix related commands, scripts and those things, and Java, because few people are purely from database background or mainframe background, they need to know understanding of Java programs. That's we need to have separate Java recordings classes I'll send you. Those you can listen, you can understand the Java. If separate required, yes, we are going to have separate Java and Unix training also, but Unix doesn't require. If required, separate Java training we can take. Otherwise, by listening to those recordings, you can understand the process. At any time, you can call us and we will also help you for practice or even at work time when you're working. You got some doubt or how to create a program or how to execute that one or something. You can call us. We will also help you to create those work as well. Okay, that's what we are going to provide in our 45 hours of duration. In our class, 45 to 50 hours of duration it will take. Any questions? Anyone having any questions?
Yeah, it was really a nice informational session. The only question I have is what is the most used language to write a MapReduce programs? Is it Java or
language is Java only?
Okay.
That's what I'm also giving Java.
Okay. So you will be sending us those videos that you just talk about for Java?
Yes, every day, right, yes. Those videos, so first class itself, once you are confirmed for the class, these slides and materials, or the materials I am going to share, these are the materials, see.
Okay.
These are the materials, all plenty of materials, MapReduce programs, big scripts, Hive queries, and class PPTs which I am using here in class. After completion of every class, the class recording also will be shared.
Okay. Yeah. Everything is covered, so I like the overview that you gave.